Hi, it's Carly McAvoy. I'm continuing the midterm review and I'm looking at word problems. If you feel comfortable with word problems that you've been doing this quarter, and I put them up here on the screen for you to see, then you don't need to watch the video, but if you're having trouble with those, you may want to watch them. And the first one, an investment company sees that one of its funds that initially started at $500,000 is increasing by $120,000 per day. If the fund continues to grow at the same rate, how many days would it take for the fund to have increased by, to $15 million? So we want it to have increased up to that. We know, we'll say that D equals the number of days. And we have a starting point and we have what we want it to end at. So we know that it started at 500,000. So we have 500,000 looks like 500,000, right? I'm going to change everything kind of into millions because that's what we're shooting for. Plus, we have an increase of $120,000 every day. So I'm going to multiply that times D times 120,000 per day. And what I want to end up with is 15 million. So I could have written this as 0.5 million, and this is 0.12 million, and that is 15. I went ahead and put the zeros in. So I kind of changed my mind halfway through that I wanted to do that. But now I can solve this problem by first subtracting 500,000 from both sides. That's 500,000. And then I'm going to have 120,000 D over here, and I'm going to divide that into what I get. So I'm going to have 14,500,000 because I have 15 million. 1, 2, 3, 4, 5, 6 zeros minus 500,000 is 14,500,000. And I knew that, but I want to then divide that by 120,000 that I'm getting per day. So I'm dividing this side and this side by 120,000. And that tells me that in 120.8333 is what I'm getting days I'm going to be there. But I just want to know, okay, after 120 days, am I at 15 million? Not quite. I need almost another day. So I'm going to say it's going to take about 121 days to get to that. 120 is not quite enough. So I need 121 days to really solidly be at 15 million. Okay, the next one just says 3 times a number is worth 6 less than 5 times a number. Sometimes I write the problems and then I change them and I forget to change a word. Is equal to 6 less than. Maybe it could be worth, but that sounds a little funny. 3 times a number. Let's say X is my number. 3 times a number is then 3x is equal to 6 less than 5 times the number. Well, remember when I say 6 less than something, that something has to come first. So I'm going to do 5 times a number minus 6. To solve that, I'm going to subtract 5x from both sides, which is going to give me negative 2x. And then I'm going to divide both sides by negative 2, and I'm going to get x equals 3. The number is 3. 3 times 3 is 9. And 3 times 5 is 15 minus 6 is also 9. So the answer is 3. Setting up the equation there is the hard part. Okay, the population of Lamar is 18 less than 5 times the population of Liberal. If the combined population of the two towns is 4,698, how many people live in each town? Well, let's say that L equals, they're both L's, so that's kind of confusing. I better say X. I don't want to make L because they both do that. X equals the population of Liberal. Why did I choose liberal? Well, because Lamar is based on liberal. So I'm going to use liberal as my population base. That means Lamar is 18 less than 5 times that. So the population of Lamar is 5 times liberal, but 18 less. So 5x minus 18. Does that make sense? Now, if we combine those two populations together, we should get 4,698. So x is the population of liberal, and 5x minus 18 is the population of Lamar. And if I combine those together, I get 4,698. This is not fictitious towns, but fictitious numbers. So I'm going to add 5x and x together to get 6x. Notice I have parentheses there, but I didn't really need them. I just put them on there. And then I'm going to add 18 to both sides. So I have 4,698 plus 18, and that is 4,716, and I'm going to have 6x. So then I'm going to divide both sides by 6, 786. Is that the population of liberal or Lamar? Well, it's liberal because we set up here x was liberal. So the population of liberal is 786. How do we figure out the population of Lamar? Well, we take 5 times 786 and subtract 18. So let's do that. Times 5, I already had 786 in there, times 5, but then minus 18 means that the population is 3,912 in Lamar. Notice that I'm stating my variables, what they are, showing the equation, and then I'm stating my answer very clearly. One more. 2 trains leave at the same time traveling in opposite directions. Here's where I start maybe, and then one of them's going this way and the other one's going that way. The faster train is going 20 miles per hour faster than the slower train. So let's say that the rate of the slower train, this one didn't go as far, is r. Then the faster train going this way, the faster train's rate is r plus 20. It's going 20 miles per hour faster. After 3 hours, they are 650 miles apart. How fast is each train traveling? Remember that distance equals rate times time. And in this case, distance of slow train plus the distance of fast train is equal to 650 miles. Well, the distance is rate times time. They were traveling for 3 hours. 3 hours times r, that's the slow train, plus 3 hours times r plus 20, that's the fast train, that's 650. Because distance is rate times time. Both of their times were 3 hours. One of them was going r and the other r plus 20. So that gives me 3r plus 3r plus 60 is 650. 3r and 3r is 6r, and subtract 60 from both sides, and you get 590. And of course, you can always do any of that work on your calculator. That's fine. I get 590. Then I'm going to divide by 6, and I get 98.33. I don't know. I thought I did something a little nicer than that. Did I make a mistake somewhere? R plus 20 in R, and the whole thing is 650. Well, I might have made a mistake when I was doing it, but we can live with this. If the rate is 98, that's the slow train. Slow train is going 98 1/3 miles per hour. So the fast train is going 20 miles per hour faster, or 118 1/3 miles per hour. I think on your test, I'd probably have those coming out a little bit nicer, but you can work with 1/3. That's not so big, such a big deal. All right, have a fantastic day. We'll see you next time.